All right, so now we have the follow-up question and the alternative example that's not quite as free. When your resistors are in parallel, then that means that there are multiple current loops that can run around next to each other. So think parallel lines run next to each other. This means, unfortunately, that a portion of the current will go across this resistor, and a different portion of the current will go across that resistor. And unfortunately, because everything is shared and split around, we end up with a bunch of fractions. So 1 over R total is equal to 1 over R1 plus 1 over R2. Now, because everything's measured in ohms, I am going to go ahead and trust that we're going to get ohms as an answer. This is already a very ugly question, so I don't want to throw in a bunch of units. Trying to work this down, 1 over R total is not something we can handle right now, but here, 1 over R1, we can set 1 over 27.66. And then for the other one, similarly, 1 over 12.11. Don't forget, this is still 1 over R total, so this is not going to be the answer. Um, if you divide each of these, you're going to get an ugly decimal for each one, and then go back and add them together, and that's going to give us 0.118729, and so on, so on. Be careful because this isn't the final answer. This is, remember, 1 over R total. So that means that R total will end up being 1 over, we do the reciprocal on both sides, 1 over that decimal. And finally, that's going to give us about 8.42. Now, what's weird about this is in parallel, when you put together your resistances, you actually get a smaller number. So sometimes it's called effective resistance, because total makes you think you're adding stuff up, and that's really not quite what happened here. I mean, there was a plus sign in the formula, but because of the weird way that the fractions split and what these numbers ended up being, we actually got less resistance.